Hello everybody, welcome back to my channel, and in this video we'll be seeing how to delete a specific node from the end of a linked list. So suppose if you're given, suppose this is the linked list which you have. So it is like you have 1, 2, 3, 4, 5. You have like 5 nodes in this, and you have to delete, suppose if they say the second node from the end. So what does this mean? From the end, the second node is this one. So this node has to get deleted entirely. So how do we do it? So the way how I'm thinking in my head is that firstly we have to iterate through the entire linked list, and we have to find the size of the linked list. So how do we iterate through the entire linked list? So I'll just create a temp pointer first. So let's just create a pointer. Yeah. So here I will place my pointer. So it will be temp. Then I will be iterating this temp one by one, and till the end the temp will be going, and also I will be creating a count which will be keep on increasing its value. So let's just write the code and see. While the temp exists, so like basically while temp is not equal to null, so basically until like the temp will keep on be increasing until the temp reaches over here, where here it is like null, it reaches to the end. So until then we have to keep on be doing this thing. So we'll just push the position of temp to forward. So temp is equal to temp of next, and we will increase the value of the count. So count is equal to count plus 1, and initially I will just define in count is equal to 0. So the count value gets increased, and now what I will do is I will be like count minus n. So n is basically the node that has to get, n is the given value, n is the input which is given. So basically if you are given like suppose n is equal to 2, like this is given, like n is the nth node from the end that has to be deleted. So the count is 5, count is equal to 5. So it will be like count is equal to count minus n. This is nothing but 5 minus n. This is nothing but like 2. This is nothing but 5 minus n is equal to 2, 3. So basically maybe like count is equal to count minus n. So by now the count value gets the new value we get of the count, and we'll write while, and then we have to be creating 2 more pointers. So what I'm thinking is that I'll be creating one pointer which will be over here, and it is called as the current pointer. And also there will be one more pointer which will be called as the previous, and the previous is basically, and the null positions basically nowhere. So I'll explain you why I'm making these 2 pointers, but let's just make them. So node star current is equal to head, which is like at the beginning position, the current position is there. And also we'll be creating one more pointer which is node star previous is equal to null. And now what we'll be doing is that while the count exists, so count minus minus, so we will be like make the previous equal to the current, and we'll push the current position to the next. So current is equal to current of next. So what will happen is that by the end, so while the count exists, so basically what did we just do over here? This was the thing which we created. So if n is equal to 2 and count is 5, and so basically this third thing has to be being eliminated from the end. So basically it just means third one from the end. So we'll be like third plus 1. So that will exactly give us the second one from the end. So that will be So basically third one, so it is saying third one, so it will go over here, but maybe like third plus one, so this part has to get deleted. So this part entirely has to get deleted. No, let's just name with a different color. So this part has to get deleted. So yeah. So now what will happen is that in this part, what will happen is that previous is equal to the current. So the previous will become this, and the current will keep on be increasing. So the current will keep on be going until the count becomes 0. So at this place, the count will become 0. So by the time this while loop gets completed, what will happen is that this current we will reach till here. This previous will go till here. So basically what we'll be doing is that we will be making the next of previous and the next of current to be equal. So we'll be like previous of next is equal to the current of next. So we are basically just building, we are bridging these two things, and we'll be deleting the current in the end. So that's what is happening. So here we'll be like previous of next is equal to current of next, and we'll just delete the current. So the previous of next gets connected to this, and we are deleting the current. So this entire current will get deleted, and we have just made this bond. So this way our nodes get connected. But there is one thing, there is one specific test case where the question might fail. I mean basically the code will fail. So usually the test cases usually fail at the most extreme ends, always of the extreme cases. So what will be the extreme case over here? What if we give the input as n is equal to 5? So it will be like 5 minus 5 is 0. But the n is equal to 5 is nothing but the fifth node from the end has to be deleted. This is basically this node has to get deleted. So what will happen is that the code will run perfectly fine till here. So it will be like count is equal to 5 minus 5, which is nothing but 0. So the count will become 0. So when this while will never get executed, because 0 minus doesn't exist. So minus of 0 0, and it can't go into negative. So this part won't get executed, and this itself will throw an error. And even if this part gets executed, the previous of next is not possible, because the previous is pointed to a null, and the next of null is not possible. So basically this shit won't get executed. So in order to fix that specific test case, what we'll be doing is we'll just go to the LeetCode.com and we'll just solve the question over there. And over there I will tell you how to fix this issue. So firstly we'll be so the first step is to iterate through the entire linked list. So iterate through the LL and find the count or size. So firstly we'll be creating a temp pointer, which will be pointing to the head initially, and then it will iterate through the entire linked list. So list node star temp is equal to head. So the temp is initially at the head position, and also we will create our count is 0 initially. So while temp is not equal to null, so while the temp doesn't become null, so we'll be like we'll keep on be pushing the position of pointer to the next one. So it will be like temp is equal to temp of next, and count is equal to count plus 1. Yes. And by now we have found the count, and now we'll be like count is equal to count minus n. So the new count is found, and now we will also create our another two pointers, which is current pointer, which will be pointing to head only initially, and we'll also be like star prev, which will be at the null position, And now what will happen is that while the count exists, we'll be like the previous is equal to the current. So basically the previous will be keep on following the current one. So it'll be like a tail to the current, and we'll just also shift the position of current to current is equal to current of next. And that's pretty much it. And now we will be like previous of next, sorry, the next of previous. So basically a previous of next is equal to the next current. We just got a tongue twister or something, but the next position of previous. So basically the previous is over here, the current is over here. By the end of this while loop, the current will reach over here and the previous will be over here. So basically we'll be connecting this previous to here. So basically, what is this? The next of previous and the next of current. These two things have to be connected. And we'll also delete current, and we'll return head, so that this entire linked list will get printed, because the function is of find like this type, that type of a function which is given in the question. And yeah, so now I was talking about the test case, like what if they gave the fifth node from the end. So what if they give input as n is equal to 5, and the size of the linked list is also 5. So 5 minus 5 is 0. No, basically it's like the fifth node from the end has to be deleted. So basically this node has to be deleted. So that's in that case, what will we do? So in that case, what we'll be doing is we'll be like, if the count becomes 0, we will be like temp is equal to head, and head is equal to head of next. We'll delete temp, and we will return the head. So temp is equal to head, and we'll officially shift the position of head over here because this part has to get deleted. So this will be the new head, and temp part will get deleted. So I guess that's pretty much it. This should run our code, and we'll return the head over here itself. No need to go all the way to there. So yeah. So let's just run this code and see if it gets executed without any issues. But that is an 8. Okay, it should be this. Now we'll run it again. It got accepted. All our test cases were passed. Everything is basically great. And now we'll just submit it and see if it gets submitted. Yes, our code just got submitted. So thank you so much for watching the video. Until next time, goodbye. And